This is a video tutorial for a lab working with map projections, and in this particular lab we're going to be covering what's called a reproject or projection. So we're taking features from one system and reprojecting them into another system. And there's several different reasons why we might do this. We want to create consistency across our layers in terms of their map projections. We also may want to calculate within attribute tables, especially for vector features, some geometry unit that we can utilize to understand aerial units. So we might want to figure out what's the square area of a polygon, or what's the distance of a polyline, and reprojecting your features into a map projection of planar units is helpful to do that process. So I'm going to talk through some of the specifics of why we want to do this as we're going along. This is an overview of what we're going to be doing here in this tutorial. We're going to be utilizing the New York Zillow neighborhood boundaries as our feature data set that we'll be reprojecting. We're going to be reprojecting into the UTM zone. So we need to understand what is the UTM zone reference grid. Where is this actually located? Where are these features located that we're interested in reprojecting? And we're just going to use the New York State boundary file, which is the state boundary for reference. Okay, so we'll be going through doing several things here. So we'll transform our neighborhood boundary from NAD 1983 into UTM zone 18 north to get planar units, and then we'll calculate some geometry in the attribute table. Okay, so to get started, if you're doing this work with me and using the video outside of this particular assignment, which is for a class, you can reference the Zillow neighborhood boundaries. So here we have all the states. We're going to be using New York neighborhood boundaries for this particular demonstration. So let me go ahead and get started here. I'm just going to collapse this and get into a working session within ArcGIS. Here you can see I have a folder set up called NAD83_UTM-Z18 North, and within that folder I have an exports folder that's empty. I have my New York State boundaries, my UTM zone, and my Zillow neighborhood features. I'm going to drop these in first so we understand what these are about. So they come in, and this is a data set that features all the Zillow neighborhood boundaries in New York State. And you can see they're concentrated in urban areas, so we can see some upstate cities and then also the 5 boroughs for New York. And this, of course, is being used by Zillow to understand neighborhoods. So properties within each one of these get a distinct neighborhood characteristic or attribute. So what we're interested in doing is just reprojecting this file and understanding why we want to do that, and I'll explain that as we're going along. So to get started here, let's just give a reference, a New York State boundary reference here also. So I'm going to drop in the state file, so we have that. So it's sitting behind the Zillow boundaries, and that gives us a little bit more context. What's also important here to understand is that under properties, if I go to the source of the property, I can see the actual coordinate system. So in this case, it's a geographic coordinate system, and it's listing it as GCS North America 1983. Importantly, notice that the datum is different. So the datum, this is the North American 1983 datum. This is very common especially in contiguous 48 states that we're utilizing what's called NAD 1983. Okay, and it's an angular unit within this particular system. And we can see that down the lower right-hand side. It lists at decimal degrees. And it's operating on a principle, which is whatever comes in first sets the data frame properties by default. So if you put in something else that was not decimal degrees or was not a geographic coordinate system of GCS North America 1983, it would set the data frame properties to something else. But because we put in Zillow neighborhood boundaries first and it belongs to this particular system, it's going to see that within the data frame. Go ahead and say OK. Now let's go to state and look at state properties. Now under state properties, we're going to see a slightly different system here. So no longer are we in a geographic coordinate system, we're actually in a projected coordinate system. It's referencing NAD 83 here, okay, but it's in the UTM zone 18 north, and it's based on a map projection called Traverse Mercator, which is a cylindrical projection. We would have talked about that in our lecture, what type of projection surface that is. We can see that it's no longer angular degrees, it's actually a meter, and it has a central meridian that's not Greenwich, it's actually minus 75. And the reason for that is that if we come over we drag our cursor over the top of our features here, we can see that we're really close to minus 75, minus 74, minus 73 on the eastern edge of New York. This is essentially the UTM zone. Central Meridian is right in this area, so it's highly specialized to a specific longitude location. To test this out a little bit further, let's go and bring in our UTM zone. So that's sitting within this folder called UTM zone that I've downloaded, that was referenced in the assignment page or in the lab page. And here I get a warning. So this is a common warning that shows up. And what this tells us is that whatever the feature is that's coming in has a different geographic coordinate system than what's already in the data frame. And remember, in our data frame currently, we put in Zillow neighborhoods and it specified the data frame as being NAD 83. Now NAD 83 is not WGS 1984. And so that's why we're getting this error. Now we're allowed to proceed because of the principle of what's called on-the-fly projection, which means that ArcGIS is able to do the transformations necessary for us to see the features on the fly. But what's really critical here to understand is that we are not changing the actual system behind the feature itself. We have to actually go in and do a transformation to accomplish that. Okay, I'm just going to go ahead and say close and drop this in, and it comes in, and we're not going to see that warning again for a little bit. So let's go to zoom to layer. So this is our UTM zone, and we can see it's broken into these grids. Let's put a label on these grids so we understand what's taking place here. So with the labels, I'll just click on the label and put it to zone and say OK. And we can see that we go from 1 to 60. So those 1 to 60 zones. And it doesn't say it on the labeling, but there's south below the equator and north above the equator. So oftentimes you'll see something like 17N. So in our case, we're interested in 18N, 18 north. Okay, so that's this line right here. So this line is going to be where our features are located, the bulk of them. Let's do this. Let's put UTM zone underneath Zillow and underneath state and zoom in to New York State. Okay, so here in this case we can see that New York State spans two UTM zones, 17 on the west and 18 for the bulk of the features. And it actually has a little bit of Long Island that pushes into zone 19. But the bulk of the state is located here within UTM zone 18 north. So if I wanted to, it would make sense to reproject most of my features within the Zillow feature class or feature data set into zone 18, especially if I'm mapping down here in the 5 boroughs, because these are fully within zone 18. So a lot of data that's held at the state level is actually already in a map projection system for UTM zone 18 north. So it's very typical if you're mapping in New York to come across that particular map projection. Now, the accuracy within the zone is the scale is quite accurate. As soon as you cast it to this particular zone, but you're doing mapping, large scale mapping in say 17 or over here in 19, you're introducing a fair amount of, or not, I shouldn't say a fair amount, but you're introducing some inaccuracy in terms of scale. If you are doing large scale mapping and you know that it's specific to this location on the western side of the state, you would probably be better to reproject into zone 17 north. So hopefully that makes sense, my explanation here of we want to make sure that we understand where our features are located within the UTM zone grids if we're utilizing this particular map projection, which is common for larger scale mapping. It's highly accurate within the grid space that where all the features are located. Okay, so it's good to understand UTM and be able to work with it effectively. And there's lots of different shapefiles that you can get online that represent the UTM zones. So this particular one is in WGS 1984, but it's representing the zone locations correctly. And a lot of these are in WGS 84, and you just drop them in on top of features if you're trying to figure out what the zone is for your mapping. Okay, so once we have that figured out, we know that we would want to be in zone 18 for the bulk of our Zillow features. What we can do now is we can actually do the reprojection process. So what we're trying to accomplish here, if we go to properties, is we want to change at the base level this. So right now it's listing it out as this particular geographic coordinate system, but we want it to be not this, but something different, in this case, UTM Zone 18. Okay, so we're going to do that process together now. So the way that this works is we go up to our toolbox, and we're going to go into the folder called going to go into Data Management Tools. And under Data Management Tools, we'll find Projections and Transformations. Okay, and here we got two options. We can either define the projection or project. So if we click on Define the Projection and put it in our Zillow boundaries, it's going to give us a little warning because we already have a projection. Okay, it already recognizes this particular projection, so it's not going to let us proceed, which is exactly as we would expect. What we really want to do here is we want to reproject, or what's the tool's called project. And so here we're going to input Zillow boundaries, and we're going to output. I've set up a folder called exports, so let's push to exports. So I'm going to call this ZB for Zillow boundaries underscore UTM Z18N for UTM Zone 18 North, and I'll say save. Now, I haven't set the output coordinate system, so that's what I need to make sure that I do, and I can do it through this little tool over here with this little pointing finger to a piece of paper, and we can set it up here. Now, let's go over this space. First, we have favorites. These are things you can star your different systems that you use on a regular basis, and you can just get to them through favorites, which is convenient. It also has a listing of projected coordinate systems versus geographic coordinate systems. So if you know that you're interested in mapping, say, a project in Africa, and you want to use one of these systems, maybe you're doing something in Egypt, and this one is obviously titled Egypt, and it gives you a sort of overview of what the actual system does. In this case, it has a datum that's specific to Egypt called Egypt 1930 datum. It tells you where the prime meridian of this particular system is. It tells you that it's a degree, an angular degree, and it tells you a little bit about the spheroid that it's based on here, the semi-minor and major axis. Okay, this is a little bit technical information. You usually don't need this, but it is really good to keep an eye on the datum and what type of units that you're using. So let's go back up. Oh, let me get out of here and go into the projected box. So in the projected box, we can see it's organized in a similar fashion. So we have world, UTM, state systems. So all our state planes are located in this box called state plane. And you can see they're organized also by the datums. So NAD 83 is very typical of the state planes, especially in the United States. We're going to be working in the UTM folder here. Okay. So there's a couple ways you can get into these if you know exactly where you want to go. And so NAD 1983, and I would push into this folder and find the actual Zone 18. So here it is, it's sitting right here. The other option is to do this kind of cheating. So the way that we can do that is we can use import, which is available from this icon. If we know that there's a feature that already has the projection that we're interested in. Okay, so we could go into, say, New York State boundary, click on boundary, and adopt the properties of this particular file. And the state file is already in UTM Zone 18 North. So we could essentially steal it or import it from this particular feature, and that would be a good cheat to use. Okay, I'm not going to do that. I'm going to start back over again and show you another way to do this. If I know the name of the system, okay, and what I can do is I can get that. Let's go over to state here and go to properties, and I'm going to copy the name. So here's the name of it, projected coordinate system. It has a name, and I'm just going to copy that, and then I'll go over here and I'll just paste it in this box right here, and then it's going to point it. It's just sitting in my favorites, but if I didn't have my favorites, it can also point me to the projected coordinate system box, which is right here, and you can see that it gives you a quick hierarchy to that particular feature that you named, or not the feature, but the projection system that you named. Okay, that's another cheat to get right into it, because there are lots of different options. There's 4,000 plus within ArcGIS, so you need to be very cognizant of what you're trying to project into and find that particular projection within its database, its integral database for map projections. And if you can, quote, cheat off something that you already have, or if you know the name of it and you can do a search by name, that can kind of speed this process up. So I go ahead and say OK. And you notice here that I'm not getting anything that comes into either one of these dialog windows. And the reason is because there's no geographic transformation that needs to be done. The geographic transformation will need to be done if you're going from one geographic coordinate system into another geographic coordinate system. So for instance, if you're going from, say, WGS 1984 into NAD 1983, you would need a geographic transformation. In this case, we already have an input coordinate system of North American, or NAD 1983, and we know that the datum behind this particular map projection is also NAD 1983, so it doesn't need to do a transformation. Okay, sometimes you need to do a transformation and it'll show up in this dialog window, and it can be an extra step of work to do the correct transformation. Say OK. And now nothing's going to happen in your table of contents because we asked the tool just to simply do a map projection. We didn't say do the map projection and bring it into table of contents. So that's what we're going to do now. So we have to always, once we do a map projection transformation and we want to bring it into our current map, we need to go find it. So in this case, it's an export, and here it is. Okay, and then it drops in, and this particular feature, let's change the color of it. So let's make it blue so we know that it's there. It's sitting on top as blue. Now we don't see a visual transformation going on because remember the data frame properties were already set early on in this particular mapping. They were set by the first feature that we dropped in, which if I recall correctly was Zillow neighborhood boundaries. And if we go to the properties of Zillow neighborhood boundaries, we're going to see that it's a geographic coordinate system and it's in degrees. Okay, so everything's going to snap to this within the data frame regardless of the reprojecting that we do per feature. Okay, so the rule here is that data frame property that's first set within an MXD mapping session is going to supersede any particular layer because of the principle called on-the-fly projection. Now, we usually, if we're doing a map projection transformation, we usually are doing it for some reason and we want to see the results also. So in this case, we want to see the new feature under its new projection system. What we can do is we can create either a new data frame on the same map page, or we can simply create a new MXD, which I'm going to do right now. I'm just going to make a blank map and say OK. And I'm not going to save any of these changes. Because remember, the changes are happening at the feature class level. So let's drop in now. Let's put in our UTM zone 18 north, Zillow boundaries, and we can see that visually it's quite different. Okay, it doesn't look like it's slouched on its side off to the right-hand side. It looks like it's much more upright. And UTM does a really good job with area, with getting the correct area, especially of polygons. So any calculation that we do to understand area now is going to be very accurate within our particular zone. We're going to lose some accuracy when we do this transformation on the western edge and on the eastern edge because that's in zone 17 and zone 19. But certainly for these features that are sitting within the 5 boroughs within zone 18 is going to be quite accurate. So let's do that transformation together. So or I shouldn't say transformation, let's do that calculation. So if we open up our attribute table, we're going to add a field. And since these are polygons, I'm interested in the area of the polygons, and that's going to be measured in square units, square area units. So I'm going to call this square underscore area, and let's have it be in kilometers. So I'm going to call it km. Okay, I'll be able to pick my unit. So here we'll go to double and say OK. So it makes a column. Nothing's in it right now. What we do is we go to calculate geometry. In ArcGIS, this is how we calculate the geometry. We use this option. And what property are you interested in? So I could do the perimeter, a measurement of the perimeter. I could also get the X and the Y coordinate of these polygons. Really what I'm interested in is area. It's 9 times out of 10, it's going to be that. And I have 2 options now. I can use the data frame, but the data frame is the same as the coordinate system of the data source because remember, we're using that first in sets the property of the data frame. Okay. So I'm just going to use this particular coordinate system that's sitting within the data source itself, and I get to pick my units now. So if I wanted to understand acres or I wanted to understand, say, square meters or square miles, I could do that. In this case, I want square kilometers, so I'm going to say square km and run the tool, say OK. And then this gives me a listing sort. I'll sort it. So I have some very small ones. Let's select some of these small ones and see where they're located. Okay, so these are little neighborhoods, relatively small neighborhoods throughout the 5 boroughs here. Okay, and our big ones are going to probably be out in the more suburban areas. Let's pick some of these guys out of those. So these are in more suburban locations, the larger ones, and that makes sense. They're covering more square area. Okay, so what's important here is that we understand now the square area for each one of those polygons, whereas before we didn't have that because we were in decimal degrees. Okay, we didn't have that particular calculation. And this is a typical use of using a projected coordinate system, is that we want to utilize planar units to do GIS tasks, and we may want to have it actually in the attribute table. What exactly is the square area? So this is all leading up to work that we'll be doing for GIS analysis work, is understanding how to do aerial calculations within features. Okay, so hopefully this gets us set up on understanding. Let's review this real quickly. So what we've done here is we've gone from NAD 83. Okay, we did a map projection transformation into UTM zone 18 north. We utilized a UTM reference grid to understand what would be the correct UTM zone to recast our features, in this case the Zillow neighborhood boundaries. We used the New York State boundary just for reference to understand where we were located. And importantly, we calculated some geometry in the attribute table. And then we just did a quick sort on the smallest to the largest neighborhood boundaries. We just quickly kind of reviewed those and saw that there was a difference in suburban versus urban sizes, generally. So hopefully this is helpful in understanding how to do a map projection transformation at the feature level. And remember, it has repercussions for the data frame. And we talked about the on-the-fly projection property of ArcGIS. Whatever comes in first sets the data frame properties. And also, if we have other features that are not in the same coordinate system or not in the same map projection, they can also be displayed on top of whatever set the data frame properties based on the principle of on-the-fly projection.